Now on the other hand, this is a representation of semi-final four quarter-final matches in a World Cup, I think a few World Cups back, where these 8 countries faced each other, and you can kind of figure out what it is trying to represent, right? Can you tell me what the green lines are about? You guys are all football fans, no? You go and play football, you should be able to tell. Yeah. Yes, Adesh, tell me. Yeah, what are the green vertical lines? Possession, ball possession, right? You will notice that if a team has a green, the other team does not have a green, in the corresponding vertical position, right? Okay, what are the blue triangles? Shots at goal, okay? And the red circle? Goal, okay? And you have this marker, right? 0, 45, 90, which is the duration of the game, right? So you have a half time, and then there are 2 big segments of the play, and this is about it, right? I mean, you cannot make, and the funny thing about this measurement, I mean, they have attempted to measure something here, right? So the thicker the green line means the longer the possession is. So at a glance, you will get that Mexico has possessed, kind of dominated the play, right? The ball is been in their possession, right? Yet, look at the result. It is a draw, right? And look at the next match, where there are way more blue triangles that France has than Uruguay, right? So France has had more opportunities to for a goal, yet none of them converted into a goal, right? And then yet the match ended in a draw. So it seems that none of these measurements are about the final outcome, right? It doesn't matter which team possesses the more. It may be that a team that possesses the least also can end up as a winning team. The number of shots at goal does not translate to more goals, and that's about it. It doesn't, it doesn't have any bearing on the outcome or the final performance, right? Why is that? Is there something about the nature of the game which is different? But can we measure individual performances here? Like, for example, if you have an equivalent chart which shows how many each player possessed, okay? Like individual, even there, there have been measurements done like that also. Like, for example, in a match, how much time Messi possessed the ball. There are even measurements about how much distance he covered, right? You will notice that, they will say that, in the entire match, Messi ran like 12 kilometers or something like that, which is like ridiculous. But then, that's how much they run, okay? So amount of running around in the field, the amount of, possessing the ball, and there are like passes, okay? How many passes one guy made, okay? How many assists, right? Passes are general passes, and assists are when you are able to pass that eventually becomes a goal, right? And so on, okay? And then for goalkeepers, there are like saves and so on, right? I mean, individual performances are also measured, but then again, it does not reflect on a player's quality, right? It is possible that a person did not possess the ball for much of the time, did not make significant passes or something like that. Maybe he was in a position to control the game in a manner that actually influenced the game a lot, okay? So there is, the nature of the games are different, right? So what is it about soccer that makes it hard to quantify, and what is it about cricket or basketball or tennis that it is easy to measure? Now think about the structure of the game. It will tell you something about measurement. Number of, yeah, I mean, you're kind of getting close there. The quantity of units that can be easily separated and analyzed is the difference, key difference, right? So in soccer, you cannot separate them, right? They are organically connected to each other, okay? So it's a flow which actually, for example, a stupid pass or something like a steal or something like that, a guy trips and falls and then concedes the ball at the right juncture, and then a series of very fortunate events happen for the opponent team, and then it converts into a goal, right? So it seems that, the separation is the problem here, right? So the ability to discretize a game, right, is much better in some games than you cannot chop a soccer game into individual parts that can be measured. In cricket, you have very discrete parts. Okay, there is innings, there is overs, there are balls, runs, wickets, catches, and so on. In basketball, it's points, assists, rebounds, and then every play in basketball is limited or fixed to this 24-second clock, right? So every 24 seconds, the play stops actually, right? At the end of every over, the play stops. In between balls, the play stops. Okay? In soccer, it doesn't stop. Okay? Unless it's a foul or the ball goes out of bounds, or it is a half time, right? And so on and so forth. Okay? This is in tennis, right? For soccer, the only apparent unit that separates is this 50 half-time mark and the other two I mentioned, right? Changes in possession could be another measure, number of passes, shots at goal, etc. So there have been a lot of attempts, right? You can just Google it, you will find some interesting analysis of soccer games where people have struggled to quantify performance, right? And what happens on the field to the outcome, right? They have not been very good successful attempts, right? There are some good links that I have provided, places where you can get started. People have done some interesting visualization of soccer games also, right? And over a period of time, they are able to somehow approximately quantify star players like Messi and all that. Okay, so that is, so it's also about the source of the data, right? What generates the data? Sometimes the source of the data can provide you with a continuous stream of data that is hard to separate and therefore difficult to quantify, right? That can have a bearing on eventually how something is measured. There are so many factors that happen in a game that it's very difficult to do it. It is not simply. Okay. So there are these four things that we are going to cover, in trying to understand the characteristics. Okay, the first one is called data semantics, and I will go through each one of them in a lot more detail with examples, then so that it becomes clearer. Data semantics are real-world meanings of the data, such as weather data, represent temperature or height measurements. It focuses on organizing the data that reflects the basic meaning, okay, rather than solely or primarily the relationship between the attributes of the data. Okay, so there are highs and lows. There is cold and hot and cold, right? There is tall and short. Okay, so there is an inherent shape to the data. Okay, there is a linearity, like a progression forward or a retreat backwards, right? So these all, I mean, there is a meaning to this and there is a shape to the data itself, right? So there is an inherent meaning to the data. We'll come to that, with examples. There is a behavior encompasses the trend, patterns, and shapes of data values relative to each other. Okay. Data type is the level or scale of measurements that describe the nature of information within the numbers assigned to the variables. Okay. So the third part we are going to spend some time because this is what directly helps you with the encoding part, right? The data type will have relation to the encoding type also. So there are certain data types which are completely unsuitable for certain visual attributes. Okay. We saw some examples earlier, which is that if you have a gradated saturation level, you cannot use that for categorical data, right? For the simple reason that a gradated saturation encoding implies, what does it imply? Some order, okay? So it is not suitable for a categorical data. So you just cannot use it, right? So that means it conveys a completely wrong meaning, okay? So the type and the attribute should be matched well. And then there is something called a derived data where you have a data set and then you derive further data from the available data set, right? For example, if it's just a table, you can, for example, compute the average, okay, which is not part of the data set, right? So you will work on the data set in order to, so you derive additional data from the original data values, and or you can add some additional data. Okay, for example, in the example of the representation of certain states in IDC, for example, in order to understand the whole story, maybe you have to bring in another data set, right, in order to confirm or validate your own conclusions. Okay, so this is the paper from which I'm referring many of these theories from. I've also provided a copy of that in the Google Classroom. By the way, I've also uploaded all the previous lectures material so far that has happened, including Rasage's lecture slides, and I've also added a few additional resources there. So you might want to catch up with them. Okay, so the first two characteristics, that is semantics and behavior, are inherent to data and are not decided or modified in the process of creating a visualization. Okay. So, for example, if it is a linear data, right, that indicates some kind of a trend, I mean, it is a linear data, it already has an inherent value to it. You cannot now convert it into a discrete data, right. As a designer, you cannot do that, okay, but they are critical for a designer to understand, that you need to understand them, understand these two things. Okay. Now, the next two is something that is under your control, right. The later two characteristics are important part of the design process itself. When working with data, specifically designers have the freedom to create, define and modify data structures and derive data. You can figure out what you want to do with the data, and you can also understand the data types in order to match it with the right visual attributes. So, we saw this, that there are these 4 elements that create the characteristic or contribute to the characteristic of data: semantics, behavior, type, and something that you can do with the data that you can derive and then make some additional data. Okay. So, we are going to see each of them, and we also saw that the top 2 are inherent to the data, and then the later 2 are something that we are free to manipulate. Okay. So, let us start with the first one, which is the semantics, or the real world meanings of the data, such as whether the data represent temperature or height measurements, right. So, there is an inherent meaning to it, right. Naturally, they map to the visual attributes, that say if you want to show increasing versus decreasing, right, the data can tell you whether it is increasing or decreasing, and there are some conventions that we understand, right, up and down, for example, right, or it goes left or right. Okay. So, there are some, or connections, for example, right, we use that there is the connection between two data, the relationship, the strength of relationship, right. These are all inherent to the data, and they have a natural meaning in terms of how we understand and interpret it, right. So, the most natural thing for us to do is to ensure that that natural mapping is not disturbed in any way, right. You do not encode it counterintuitively. Okay. We saw some very simple examples in interface design course that you did last year, which is that if you want to show two controls which show a lift going up or down, what would be the most natural placement for those two buttons, right, would be up and down, right, and you will still find some lift controls which are placed left and right. Okay. So, that is counterintuitive, right. Even more counterintuitive to swap these positions and then put the down button up and down and then up button down, right, that would be even confusing, right. So, when there is a natural meaning to the inherent to the data, exploit that. Okay. If you are not able to exploit it, at least do not do anything that is counterintuitive to how people interpret and understand it, right. So, that is a very simple thing, right. So, colors, most of the time there is a semantical association, right. So, fruits have some colors, right. So, if you are representing a data set which comprises of fruits, then you would use the natural colors of the fruit, so that when people read it, they will be able to do it. Suppose you counterintuitively or by default, whichever the tool that you are using, and then allow the tool to just slap on any color to this data set, it will just arbitrarily assign some colors, right. It will not be natural. Sometimes it might coincidentally match, but most of the time it might not, right? And that takes a little bit extra cognitive effort to understand it, right? So this is what we call as semantically resonant colors, right? There is also some forced meaning that you can give. Okay, the first one is whatever is natural, use it, right? And or don't go against it. The second one is you discover a most appropriate meaning for the data set and the representation you want. Okay, we see example of that using this Vietnam War Memorial. Okay, so this is the first one, which are some naturally occurring meaning. Okay, the first one is a semantically resonant color coding, right? Where apple is green, banana is also some kind of a green, blueberry is blue, cherry is red, peach is peachish color, and then tangerine is orange, right? So this requires maybe sometimes manually encoding this, right? If you just allow the software to assign these colors, it will do some random assignment like the one that you see on the right. Okay? Now you can very clearly tell that one is a superior encoding to the other, right? Because the first one is instantaneous. That second one is artificial or counterintuitive. So I mean, you don't expect a blueberry to be in red in color and a cherry to be in orange in color, right? So that's kind of, so every time you are kind of doing some computation, right? And this is unnecessary, right? Don't do that. This is what this one is there, right? And there is some excellent paper here where people have actually done empirical experiments to prove that semantically resonant colors are much easier to perceive and understand, and then they make less errors, they do it faster, right? So this is a proof that you have to take this extra effort, right? So when people do redesign exercises time and again, what would you naturally assume? For example, if you're representing political data, right, election results. Now there are some not naturally occurring color assignment, but some kind of a code exists, right? Parties have some chosen colors, right? What is the color for BJP? Orange. What is the color for Indian National Congress? Blue, right? These two at least are not disputed anymore, right? The regional parties, sometimes people may be aware, not aware, like for example, Bahujan Samaj Party is blue, right? Samajwadi Party is red, and in the south, right, the two major parties, which is in Tamil Nadu rather, DMK, ADMK have almost identical flags, right? Only a person from Tamil Nadu and familiar with the politics of Tamil Nadu will be able to understand the subtle differences between them. But generally, some of the even regional parties have very strong color identity, right? Because they consistently use in their branding and people are familiar. So this is something that is not naturally occurring, but as a society we are used to it, right? So this is the color coding that we also see in male versus female color coding, right? Or boys versus girls, right? So blue and pink. And there are natural occurring color coding like warm versus cold, right? Or intensity can be like higher versus lower, right? Meaning that you show like a dark intensity of a saturation can indicate higher or lower, right? The more saturated a color can automatically imply the meaning that this is more, lighter would be less, right? The positioning, right? Place it on the top, more important, place it at the bottom, less important, okay? The progression of something can indicate increasing or decreasing, okay? Outlier can be highlighted so that it pops out or stands out, right? So another example, the one that we have already seen. So again, we tend to indicate, or we understand that the good is green and bad is red, right? So there is the red is associated with things that are dangerous or below or not so preferred, versus green. Green is like the okay and accepted, green signal and all that. So these are all like forced conventions that we follow. Okay, somebody started it some time ago, and this convention kind of follows it. Okay, don't break those conventions. Right? You don't have to invent a new pair of colors to indicate good versus bad. Okay, when already a set of colors exists. This is one of the geo maps that I think Rasaki also showed, where you want to show the instantaneously the availability. Again, red is good and red is bad and green is good, right? So the more green means that the lesser time you have to wait for a cab, and then the red ones are that not so preferred, not so desirable ones, right? And you will notice in this in heat maps indicating temperature data, for example. Okay, there is a very clear association there, right? Meaningful association, right? Blue is the colder color, red is the warmer color, and therefore such things are there. Okay, so these are all look for inherent meaning in the data. There would be some natural color associations such as fruits and then their respective colors. Now you might also end up with a data set where some fruits will match some fruits, you will not be able to match it, right? What do you do in those kind of things? Like for example, you are representing some 20 parties, right? Out of that 10 parties have clearly identified colors associated with them, but 10 do not have. What do you do? Would you discard everything and then do some random assignment?
We will choose some other attributes.
Some lesser known features, maybe the second identifiers.
Yeah, something else you can do, or at least the ones that have some natural meaning, use them, right? And then for the rest of them, you can do a random assignment, right? So as far as possible, even in incomplete assignment of good color match is better than no color match at all, okay? So that's what you should do, right? So it is not, for example, you'll notice that apple and banana, both of them are green. Then how do you distinguish between them? Then the way that they have done is use different shades of green, okay? Similarly, something like cherry and another fruit could be both red, and then you show some kind of a differentiation within. So at least you can kind of you're not differentiating 10 different colors. You're only differentiating the two colors only, right? And they are kind of semantically connected with the color of the fruit itself, right? So where possible, use it. Where it is not possible, then go for an assignment. You can also include a second variable, like what Shweta was saying, right? So you can use that. In fact, if you're getting into the territory of 20 parties and all that, color is not going to be sufficient, right? Because 20 colors are impossible to distinguish. And then even Rasagya showed a palette in which you want to show 20 categories. Then you come up with 20 different hues. Impossible, right? I mean, hues for categories work for small numbers, maybe 7 plus or minus 2 is good enough, but anything beyond that, then it becomes harder. So in a way, that semantical assignment kind of helps to increase this number. Okay, if it is more semantic, you can even go to 10 or 12 or 15, right? And it still makes sense. Okay, so this is one. Okay, the second one is that can we discover or impose meaning by the way you encode it, okay? And she proposed a very simple design of a wall, okay, in which the names of all soldiers were inscribed, okay? Now this became a point because these soldiers lost in different battles in different locations in Vietnam, right? And some of their remains came back and they were buried here, and many of them probably did not even come back, right? So this became like a common point at which the loved ones can come together and remember them, right? And there is a Memorial Day weekend, which is a very big thing in the US, and where all veterans who lost their lives both in all kinds of wars are all remembered, right? So now the problem was how do you organize these names? Alphabetical, okay. The first thing that would come to somebody's mind would be that, right? Okay, let them put because it serves a purpose, because there are thousands of names there. We saw earlier in the day how if you have a lot of names, a lot of nominal data, one of the best way to search and find it is through an alphabetical listing, right? Okay. Any other? Their position means that the rank, right? A rank in the army, okay? So corporals, sergeant, major, lieutenant, whatever, right? All kinds of, so they can be categorized according to them. Yeah, somebody here? Year of death could be other. Year they served, okay. Okay, so you have these years in which they died, and under that would be alphabetical. So you can have kind of two organizations, right? One larger organization and then a smaller organization.
Also, day on which they died.
Day on which they died, okay.
Also, like to categorize this more further, we can do this like Pratham said, on the rank basis, and also the places where they all serve together.
Okay, where which location, which battlefield? Okay. Their states of origin could be one thing, right? You know, Alabama, you know, Washington, California, Texas.
I don't know what they're called, but
Okay, so the platoon or the battalion, right? Yes, yeah. Okay. So you can see, I mean, you can even think of more frivolous organizations such as like males and females, or I don't know, like age, for example, the youngest to the oldest, right? Now the question is really this, right? You know, so this memorial is not about pragmatism, right? It is something that is emotional, right? The experience that you want to evoke is an emotional one rather than ease of use. It's not a directory where you want to find the fastest way the person that you're looking for. You are coming there to pay respect, contemplate, and to contemplate the sacrifice, and maybe, you know, think about war and death, and you know, and your relationship with the person that you lost in the war, etc., right? So it's supposed to be a poignant moment, right? And therefore, what is now? I'm going to ask you the same question, right? What is the organization that evokes this respect and poignancy, right? Rather than pragmatically, which is the most efficient way to organize. Their battlefield. Eh? Okay, so that is exactly what happened. I think a combination of some of your answers was eventually the proposed organization, which was that, you know, these were organized on the days in which they died. Okay, say the war lasted 2 years, it's about roughly 600, 700 days, and then every day somebody died. Okay, so if you notice, the wall actually looks like this. Okay, so there is a like they meet at this point. I'll show you an aerial shot that will. Okay, so the names are listed here like this, and it looks like this from the top, right? So there is a increasing. You can see the shape of the war, right? So war started off small skirmishes, limited engagement. One person dies in every 2-3 days or something, and then the intensity grows, right? As it grows, more battles, more people dying, and at the peak of the war, the maximum number of people dying, right? And then something dramatically changes within the US, right? There is anti-war protests, student protests were happening. There was a lot of opposition. People were questioning the government's foreign policy, right? What are we doing in Vietnam? How does it even matter to us? Why are our young boys going and dying in a foreign country, right? And the resistance grew and grew to a point that, you know, US realized its mistake, that they realized that it was an unwinnable war, and then they have to do something about it. So they decided to beat a hasty retreat, and slowly, of course, it's not something that you can pack and leave one day, right? So it has to be some kind of a gradual withdrawal, right? So they began to withdraw, and then as they began to withdraw, then you can see the deaths actually going down again and again to a point where it completely stopped. Okay, so this also tells you the story of the war, right? There is a story that is not obvious to you, but somebody who knows the history of the war will know that, you know, I mean, this is exactly you know, how the war panned out, right? And there are points at which these key moments happened, and that changed the trajectory of the war. Okay. Now, why is this more meaningful? Is because that it does not differentiate your sacrifice based on. Oh yeah, one of the trivial ones that I was thinking about, or even the more obnoxious one, is that, you know, categorize them based on their race. Okay, whites, blacks, Mexicans, and then Asians, for example. Now, how rude would that have been, right? Okay, that would be totally insensitive to do, right? Now, so what it does is that it treats everybody the same, okay? Whether you are the lowly corporal or whatever the I think private it is called, right? Whether you are you're private or whether you are a major, it doesn't matter, right? You have made the ultimate sacrifice of life, right? Giving your life to the country. You are the same. Okay, it doesn't matter. It doesn't matter whether you come from Texas or Louisiana, right? It doesn't matter whether you are a black or a white. It doesn't matter whether you are white, you are young or old. It doesn't matter whether you are a man or a woman, right? You are all the same, and therefore you have to be represented the same. Okay, so which is why in this one you also I mean any kind of an order is pushed away. The organization deliberate. Okay, so that I mean even in this there could be some preferred order that suppose if you had just listed them one after the other, it will indicate. That's why the kind of the names run like that. Okay, and every attempt is to shun ordering. Okay, any kind of ordering implies the meaning of better, not so better, right? So there is a conscious attempt to not do that. Okay, and then the day of the day that they died is important because these people died together. Okay, and if you know how army functions, the psychology of a smallest unit, right? People are not so much motivated to fight for their country, right? I mean, it is what the government will want to make you believe, right? They are actually fighting for their friends in their smallest unit, right? They are fighting for their friends. They are fighting with their friends for their friends, right? And then ultimately, all of them doing this, maybe they are fighting for the country, right? So they have a very close bond amongst themselves, right? And they are the people that they know very well. They are friends, and the families also know each other because of this friendship, right? And the fact that they died in the same battle together means a lot, rather than separating them out. Okay, so these are all the key battles on. So if on one particular day that's a maximum death, so these are some of the key battles in which the US suffered the heaviest losses, right? It's also a slice of history, okay, and that is why it was. So you would find that people will come on the day of the battle so it's basically their memorial day, right? Their anniversary or death anniversary. So they would come, place flowers like that, and then they will end up meeting other families who also lost their children, their husband, their boyfriend, or their son in the same battle. They would meet up, and they would talk about it, and kind of remember together, etc. Right? So it was in a lot of ways this sense, although from a purely information design point of view, this is a lousy organization. It is meaningful for the context of the problem, okay, and therefore it is a successful design, right? Sometimes you might have to think about this kind of. So what is the meaning or that you want to evoke with your visualization, right? And what kind of a visual encoding and style that you want to do that with, okay? So colors, for example, I think we saw some examples of some of the things, using monocolor, for example, right? I mean, why do you do that? It's, maybe it's not a most effective way from the point of view of understanding that information, but it might evoke a feeling that you may that for which you are going for, okay? And therefore, you make that way. So meaning now determines this encoding.